Welcome to ePathshala PG courses on computer science. The module is about XML Dom, and then here we are going to see about the basic concepts of XML Dom, and then we will see about the fundamentals of Dom based and SAX based parsing, and we will also discuss about the Dom model. So, basically we need to see about the XML parsers. So, parsers, actually the word comes from the compilers, and parsers are used to check the syntax of any sentence. It actually analyzes the grammatical structure of the sentence and then check whether the sentence is correct or not. So, given the formal language or given the formal grammar for any language, it describes the atomic elements, how they are coming in a sentence and how they are related in a sentence. So, using parsers will actually form a correct sentence for any language. So, here too in this concept we will see about this XML parsing and what are the standards that are basically available for doing an XML parsing. From the previous lectures we have actually understood about the basics of XML document, and then we have studied about the XML DTD and then XML schema. These are basically used for representing any XML document. Now, let us see about the different kinds of parsings that can be applied on an XML document. There are two methods implemented for doing an XML parsing, and they have been deployed as a W3 standards. So, the two methods are, one is called as SAX. In simple we call it as SAX. It is actually simple API for XML, and there is another implementation called DOM, and it can be expanded as document object model. And these are the two basic implementations for doing an XML parsing. The idea of XML parsing is, given an XML document, we are going to parse this XML document to know what is actually in the XML document. For various reasons, we will try to parse an XML document. And we know that an XML document is composed of various elements, and the elements can have attributes, text and so many things. So, here there is an XML parsing called simple API for XML. The parsing method is actually an event driven parsing, whereas the protocol that is actually applied here is called as an serial access protocol, and it is only a read only API, and it is also used as an ad hoc standard. Whereas, when you come to an document object model, it converts an XML to a tree of objects, where this protocol is actually called as an random access protocol, which means that given an XML document, we can actually construct an XML tree node, or it is called as an XML tree. And once an XML tree is got, we can actually parse this XML document randomly, or you can have a random access on an XML document. So, this protocol is actually called as an random access protocol, and we can even update an XML document using this parser. And DOM is also deployed as a W3C standard. And the basic difference between a SAX parser and a DOM parser. DOM actually reads the entire XML document into the memory and stores it as an XML tree structure. Whereas, when you see a SAX parser, this actually reads the XML document and sends an event for each element that it encounters. So, what happens is, the DOM is actually called as a random access protocol. Why? Because since the DOM reads the XML document and store it like a tree, we can actually make a random access to the XML document. SAX actually will read an XML document and sends an event for every element it encounters in the document. So, DOM actually provides a random access, whereas SAX provides a sequential access to the XML document. And DOM also requires a huge amount of memory because it has to store the entire XML document tree, whereas SAX is very fast and it will require always, it requires a very little memory, and it can be used for a large set of documents. So, it is actually the SAX parser is very popular among the web standards, or we can say that it is very popular for any website development. But some DOM implementations even allow an update to or manipulation of an XML document through this parser. So, DOM is actually providing a random access to an XML document, whereas SAX is providing a serial access. Why? Because you use a DOM parser to store the entire XML document in memory, and you can access the XML document XML tree using this parser. So, it can have a random access, whereas SAX actually for every element it encounters, it sends an event. So, it is actually called as a serial access protocol. So, once it has parsed that element, it is over, it is not stored in the memory. And then before we go into how do we do all this parsing, we need to know about the DOM model. So, DOM model is actually called as a language independent and platform independent object oriented model, and this DOM model has been developed for both XML as well as for HTML documents. So, DOM provides a specification of how to parse this XML document or HTML document. So, when you write a parser and DOM parser, it can be for an XML document or you can write it for an HTML document. So, it is actually the parser is going to be a program, or we call it as a script, and this program or script is used to build the XML document and to navigate the XML document. And one another use is that using this parser or using this program or script, we can dynamically access and manipulate the content, structure and style of a document. And it also provides a foundation for developing, querying, filtering, transformation, rendering, etc. on top of the DOM implementation, which means that if given an XML document, you can have a parser that parses the entire XML document, and you can make a query on whatever data you want to take it from the XML document. You can filter the data from the XML document. You can actually make a transformation and render it on a web page. So, like HTML, HTML is mainly useful for displaying a web document, and whereas an XML is for storing an information and it is for transferring information via the internet. So, this XML document is a text document where you have all XML elements. So, it stores a large amount of information where you can use a parser to parse the entire XML document and then find out what information you have in your XML document. So, I have read from the web that instead of calling a SAX as simple API for XML, you can also call it as a serial access XML, because this SAX parser is actually providing it is actually called as a serial access protocol, or it is actually providing a serial access to an XML document. And a DOM, and another name that is given for a DOM is that directly obtainable in memory. So, instead of calling it as document object model, there is another name for DOM called directly obtainable from in memory, which means that you try to access or parse the entire XML document and store the XML document in memory. Thereby, we provide a random access to the entire XML document. So, it is that you are obtaining information directly from the memory. So, DOM, since it is actually providing a random access to your XML document, it can also be called as directly obtainable in memory. But these are not going to be formal names, these are the names to understand what is DOM and what is the SAX parser, what are the protocols that is running behind this parsers. And then to understand more about the DOM, we know that DOM is actually a W3 standard, or it has been developed by the World Wide Web Consortium, and it is a standard for accessing any XML or HTML document. And we have 3 levels in the DOM. or the DOM specifications have been developed in 3 levels, or 3 parts are there in the DOM. One is we have a core DOM, which is actually a standard model for any structured document, and we have XML Dom specifically for designed for XML documents. So, it is a standard XML Dom is a standard model for XML documents, and we have HTML Dom, it is a standard model for HTML documents. So, the specifications can be described in 3 levels. We have a core DOM, it is applicable for any structured document, and we have DOM for XML document, we call it as XML DOM, and we have a DOM for DOM specification for HTML document, we call it as HTML DOM. And we have come into a point that we have 2 kinds of, there are specifications specifically applied for HTML documents and specifications applied for XML documents. So, what is actually you have in the DOM? We saw that it is a standard and it has some specifications. The specifications are nothing but they specify the properties and the methods to access this HTML document. And you know that in an HTML document you have HTML elements, methods, HTML elements, and you have various and text, images, video, everything. So, in order to access this HTML data, we have specifically properties that are specified in this DOM, and in order to access these properties of the HTML document, we have methods, and the data and the properties are actually encapsulated, and that is called as an object. And similarly, to access a HTML document, we can also access an XML document. So, XML document is a standard model for XML, and this XML DOM is actually providing a programming interface to access the XML document. And we know that it is actually platform independent and it is a language independent specification. So, this XML DOM also holds good for specifying the properties and methods to access the XML document and to manipulate the XML documents. And now, to understand more about DOM, we know that using this DOM, we actually create or store this XML document in a form of a tree. So, this DOM actually represents the entire XML document as a tree structure, or in turn you call it as a hierarchical structure. So, when it is actually the document is represented in the form of a tree, it has everything that is in the tree would be now called as nodes. When you have nodes, you can have relationship among the nodes, and the relationship can be represented as parent nodes or it can be a child node. So, when it comes to a context of child node, we can say that it can be a descendant node or it can be a sibling node, and since it is a tree structure, we know that for every document, an XML document has one root element. So, here too there will be a node called root node, and all the other nodes will be the part of this root node. So, we store this XML document as a tree node. So, the basic structure of the DOM model actually comprises or comes into a part of this hierarchical structure or a tree structure. So, as said before, it defines the objects, properties and methods to access and manipulate XML document. So, it holds, if we come to see what is actually in DOM, we have a lot of interfaces, and we know that an interface has a declaration of all the methods. So, the method declarations are available in the interfaces, but not the implementation. So, we have a set of interfaces that defines the set of methods to access the different kinds of elements or nodes that you have in the XML document. And within this interface, you know that every node has its own properties. To access these properties, we have methods, and all these properties and methods are binded together or encapsulated together, which we call it as an object. So, this XML DOM or HTML DOM is basically an object oriented model, or it based on the object oriented concepts. So, it is now instead of calling it as a tree node or calling it as an hierarchical structure node, we can also call it as a parse tree. Since now the entire XML document is represented as a tree structure, you can now use methods to parse the entire XML document. Now coming to the nodes. So, the DOM nodes, here we know that everything in an XML document is a node. So, in the entire document we say that the entire document we can call it as a document node, and every XML element which you can call it as an element node, and the text that are stored in XML elements are called as text node, and this element can be described with attributes which are now called as attribute node, and the comments whatever you have in the document are also called as comment nodes. So, everything that is now you are seeing in an XML document will be now called as a node. So, the entire document you call it as a document node, and then you call every element as an element node, then text node, attribute node, comment node, and so on. Now, this is a brief summary of what you actually have. So, all nodes can be accessed through the tree, and they can be modified, deleted, or you can also add new elements to the tree once you have a DOM model of your XML document. So, the entire tree shows the set of nodes and how they are all related. So, the hierarchical structure we can say that it is not even a single tree, it is going to be called as a forest of trees. Now, coming to the relationship among these nodes, we can now designate nodes as parents, children, or sibling. So, for every node there will be only one parent. Root of the document is called as the root element or the parent of all the nodes in the document. And now we say that any node would be called as a child node or called as children, and brothers and sisters of a node are actually called as sibling nodes, and then the node that comes after this node would be called as a descendant node, and a parent node or a grandparent node would be called as an ancestor nodes. Okay. And any node that does not have any other children would be called as a leaf node, and every sibling node will have the same parent. So, this is how the relationship is actually made known in an XML document. And now coming to this XML example, we can see that you have a bookstore, an element, this is called as the root element of the XML document, and under that you have an element called book element. So, you know that in an XML document every tag should be opened and closed properly. And this category is an attribute, now it is called as an attribute node. So, bookstore is an element node, book is an element node, category is an attribute node, and title is the child of this book node, and then author is also a child of this book node, and year is also a child of this book node, and then price is also a child. So, the children of this book node are title, author, year, and then price. For the title node, author, year, and price are going to be the sibling nodes, and for any of this title, author, year, and price, this bookstore will be an ancestor node or it is a grandparent node. And now looking into this DOM tree, you can see here that the root element is the bookstore, and for the book element the root bookstore is the parent element, and for the bookstore element this book element is a child element, and it has the attribute category. And now we can see that for the book element the title, author, year, price all are children, and this title has an attribute language, and then for the author each of this title element or author element or year or price you had text. So, text is also considered as an element. So, everything whatever you see in your XML document is now called as nodes. Now, coming into the parent child relationship, we know that bookstore and book, for a book this bookstore is the parent node, and for the bookstore the first book is going to be the first child, and the next book description would be called as the next child. Okay. The last book content would be called as the last child, and for the book, for the first book the next book would be called as the next sibling, or for any book the preceding one would be called as the previous sibling. So, here we know that there are methods or there are properties which actually stores all these relationship. Now, coming to this the same example, you had the bookstore example. Here the title element is the first child of the book element, and the price is going to be the last child of the book element, and the book element is going to be the parent of any of these 4 child nodes: title, author, year and price. Now, coming to the interfaces. So, as we have seen, this DOM is an object oriented model, or it is based on the object oriented concept. So, now we have seen that the entire XML document is described in terms of nodes, and these nodes have its own properties and methods. So, the DOM specification or W3 has actually specified the entire specification of all these different types of nodes. So, all these are, here we can see there are 12 kinds of nodes are there, and these nodes, these are actually the interfaces that has its own method declaration, and whenever we try to access or update or manipulate any of the XML document, we define the methods. So, here there are different kinds of nodes like the document node. This is the first node which we needed. So, the entire XML document you call it as the document node, and there is another node called document fragment, and we know that in a document you have several elements, and every of them are defined using this interface called element interface, and there is an attribute interface. Then from the node you have character data interface, then from the character data you have comment interface, and from the character data you have another text interface. All these are basic interfaces, and there are also extended interfaces which are shown here: the C data section, document type, notation, entity, entity reference and processing instruction. So, let us see about the description of each of these interfaces. So, coming to the document interface, this represents the entire XML document, and document fragment is part of the document. So, when you are trying to use the entire document interface, it is a heavyweight interface where you need to implement all the methods. So, a part of the document can be actually utilized as a lightweight document, which you call it as a document fragment to represent your XML document. And this element interface is used for representing any of the elements, and then attribute represents an attribute of an element, and text actually represents the textual content of an element node, and then you have processing instruction. This actually provides specific information about the document to the processor, and you have comments in your XML document. And then C data section is an interface. This actually does not perform any lexical checking. We know the difference between C data and parsed character data, PC data. So, this C data where no lexical checking is performed, and it is actually useful for arbitrarily storing any textual information that contains characters. Other than all these interfaces, node interfaces, you also have entity and then entity reference interfaces. Now, these interfaces are defined with constant names like as shown here. So, for an element interface, the name of the interface is element node, and attribute, the name of the interface is actually stored as attribute node. So, in order to access any of these nodes, we can use these constants or you can use these integers. So, this is to show that all these nodes can be accessed using their names, constant names, or by their integer values. And then coming to the properties, the node interface defines the properties of all the nodes, and this has been inherited by any of the other interfaces. So, the node is the basic interface, and all other interface inherits the properties of the node interface. The basic properties that are available in the node interface are node type. This actually represents the type of the context node. So, whether it is an element node or it is an attribute node or it is going to be a text node or a comment node, whatever the node type. So, as seen before the table before, we have seen that the different constant used to represent the different types of nodes. So, node type is to find out what type of node that is parsed in the document, and then node name actually represents the name of the node. It can be an element node or an attribute node or a text node or whatever it is. So, actually the node, there are several properties. All the properties doesn't holds good for all the interfaces. So, for some of the nodes for which the properties doesn't holds good will actually returns a null value. So, all these properties are for defining or for representing the basic characteristics of any of these different kinds of nodes. In order to access all these properties in Java, you will put an a get before this any of this property, so that you can access the property of that node. Supposing if you want to get the type of the node, then you have a method like get node type. Supposing you want to get the name of a node, you use a method called get node name. So, it can be any method, some xxx, putting a get before it, you can access the property using a Java program. Similarly, you have a property called node value. This actually retrieves the value of the text node, and there is a property called node list. This gives the list of all the nodes, and they can be, once the node list holds the list of nodes, it can be accessed through a method called item. So, item is like an iterative method. You will put in a for loop and then you can access each of the nodes that has been got in the node list. And then there is a property called length. This length returns the number of children in the root element. And then there is a method, there is a property called next sibling that actually returns the nodes, the next node. And parent node, this actually returns the parent of any node. And then there are other properties like child nodes. This will actually provides all the children or all child nodes, and it is only valid for the element type node. So, that is what I told, all properties doesn't holds for all the interfaces. Depends upon the node type, these properties are actually utilized in these interfaces. And first child, this refers to the first child of the context node. Last child refers to the last child of the node. Previous sibling, next sibling, similar, the preceding node or the node after it. And then attributes. So, attributes actually gives the unordered collection containing all attributes specified for the nodes. So, these are the different properties, and the methods that are used to access all these properties are listed here. You have method called get node type. As I had told you, node type is a property, and get node type is a method for it to access the type of the node. Node value is a property, and get node value of the element, and get owner document is a method that actually gets the owner of the document, and parent get parent node, and has child node is actually a boolean method that returns true or false, 1 or 0. So, if the element has child node, it returns true or else false. Similarly, get child nodes retrieves all the child nodes of any node. Get first child, get last child. So, whatever methods, whatever properties we have seen, the corresponding methods to retrieve the properties are listed here. Other than that, you have attributes. That's one property called attributes. Has attributes will check whether there are attributes for an element, and get attributes is to find out all the attributes of an element. The last 4 properties like append child, insert before, replace child, remove child, all these are for manipulating the XML document. So, DOM is a model where you can also build your XML document. You can add elements or attributes or text nodes, or you can remove, delete it, or you can even replace it. All manipulations can be done to the XML document using a DOM model. And these are the different node interfaces, names and values. So, given all these interfaces, get node name will return the name of every node. So, if it is an attribute node, it returns the name of the attribute. If it is an element node, it returns the name of the element or called as tag name. Text returns the content of text node, whereas get node value, here it returns the value of attribute for an attribute node. But if it is an element node or a text node for which you do not have any value, so it returns a null value. Similarly, for C data section, if get node name is used, then it returns simply hash C data section. But if you use a method get node value, it returns the content of the C data section or the text data. Similarly, entity reference, it returns the entity name if it is a get node name is used, and similarly you have all these things listed here. So, we can see that these methods, the node name and node value are properties, and get node name and get node value are the methods used with all these different kinds of interfaces. Depending upon what it returns, if it does not holds good, it returns a null value. That is what shown in this, actually shown in this table. Rest of the things we can see in the next module. So, we will conclude that this module we have explained about the DOM, the document object model, and we have also seen about some of the things about the DOM node interface, node types, its properties and methods. There are a lot more things. We have other different kinds of nodes for which we need to see about the properties and methods, and we have just discussed about the basics of parsing for DOM and SACS, and again we need to go in detail about the different node types, its properties and methods, and we will also see about how to write a DOM parser or a SACS parser. Thank you.